All right, everybody, welcome to the video here for lesson number 2 on long division. So here, taking a look at long division, it's just like you did it way back in elementary school. The only difference here is we have some variables and polynomials that we're dividing. So let's take a look at number 1. So number 1 says to divide this polynomial, this cubic polynomial, by 2x minus 2x plus 1. So put our 2x plus 1 on the outside of our division. And we'll put the 2x cubed minus 13x squared minus x plus 3 on the inside. So our first job is trying to eliminate that first term, 2x cubed. So I have to ask myself, what multiplies by 2x to make 2x cubed? So that would be x squared. Multiply that x squared by both the 2x and the 1. That gives us 2x cubed plus x squared. Remember here, you're subtracting. So I like to use a different color here. So I'm subtracting and subtracting. The signs change when you do subtraction. So these first terms cancel, which should happen. If not, we chose the wrong thing. And we have negative 13x squared minus 1x squared. So that's minus 14x squared. The next term comes down. So now our goal is to try and get rid of negative 14x squared. So what do I multiply by 2x to get rid of that? Would be minus 7x. That gives me the negative 14x squared, which I wanted, and minus 7x. Again, remember here you're subtracting. So since we're subtracting, this becomes a plus, and this becomes a plus. And once we've done that, these cancel. Negative x plus 7 is 6x. Positive 3 comes down. Now I have to ask myself what multiplies by 2x to make 6x. That's just plus 2. For this lesson, at the end, we should wind up getting a remainder of 0, which we do because both of these would become subtraction. So there's your answer. Number 2. Number 2 gives us x plus 2 as what we're dividing by. This we're actually going to learn in lesson 3. There's an easier way of even doing this, but we'll talk more about that on Tuesday. So if we go through and do our long division here, what multiplies by x to make 3x cubed? Well, that would be 3x squared. 3x cubed goes there. 3x squared times 2 becomes 6x squared. Remember, again, you are subtracting here. Let me just move this out of the way. So since we are subtracting, this becomes a minus and a minus. These first terms cancel. 4 minus 6 is negative 2x squareds. And the plus 7x comes down. If we multiply x by negative 2x, that gives us negative 2x squared minus 4x. This becomes a plus, this becomes a plus, and then we can cancel that first term. The reason why we're subtracting is to cancel or eliminate that first term. 7x plus 4x, well, that's 11x plus 22. What multiplies by x to make 11x? That's easy, just 11. So I have 11x plus 22. Again, these two things should be the same there, so we have a remainder of nothing. There's your answer. Number 3 is only more challenging just because there are larger exponents involved. All right, same idea. So I'm going to put my x squared minus 4 on the outside. I know there's a missing term there, but we don't really care about the missing terms when they're on the outside of the division, just really when they're on the inside. Sometimes they don't even matter. So what multiplies by x squared to make x to the 4th? Well, that would be x squared. If I multiply x squared by negative 4, that gives us negative 4x squared, which combines or is a like term to the negative 7x squared. So I want to put it over there. Remember, you want to match up your like terms. It's subtraction, so this becomes a minus, this becomes a plus, and this term, even though it's out of order, is going to come down. So I have 6x cubed, and negative 7x squared plus 4x is minus 3x squared. What multiplies by x squared to make 6x cubed would be plus 6x. That would give me a 6x cubed, which we want, and a negative 24x. Well, negative 24x doesn't combine with that, so again, I have to do some bringing down. So I'm going to bring down another term here, this minus 24x here. This becomes a minus, this becomes a plus. This term, although out of order, comes down. So what you'll notice is both this term and this term cancel, leaving you with negative 3x squared plus 12. Then what multiplies by x squared to make negative 3x squared would be negative 3. That's going to give me negative 3x squared plus 12, which we like because they're the same. So there's your answer. I would star that one in your notes. That's about as hard as I would give you one. Also, that's the level that I want you to be able to do on a quiz or a test. Number 4 is what I would call a division problem kind of in disguise. If this was on a Regents exam or even a test question, I wouldn't say use long division to find p of x. I would just say determine the expression p of x. So you have to understand that these two polynomials, 2x squared plus 1 and p of x, are being multiplied here. Well, to get p of x by itself, I can use my algebra skills, and I would divide 2x squared plus 1 to cancel here. Well, if I do that to one side, I have to do it to the other to balance out my equation. So again, it's just a long division question. So I'm going to do 2x squared plus 1 divided by 2x to the 4th plus 0x to the 3rd, notice missing term there, minus 3x squared minus or plus 0x minus 2. Essentially, you want those missing terms in there in case you get something that matters. If nothing matters, then they're kind of irrelevant terms. So let's start. So 2x to the second multiplies by x to the second to make 2x to the 4th. We want that. X squared times 1 becomes x squared. So I would go over here to put plus x squared, so it's matching its like term here, meaning this x to the 3rd didn't matter. Change your signs to a minus and a minus, and we see that this cancels. Negative 3 minus 1 is negative 4, so that's negative 4x squareds. And this x is not going to matter either, so we'll just bring down the minus 2. How do I know this 0x is not going to matter? Well, I only have 2 terms left, and I want to have a matching binomial. If not, I'd create a trinomial, which would be crazy talk. So negative 4x squared times, well, I'm sorry, 2x squared times what makes negative 4x squared? So that would be minus 2. That gives us the negative 4x squared that we want. And it'll give us a minus 2, which we want. Same term, meaning when I subtract them, nothing's left. There is p of x. So I can say p of x is the polynomial x squared minus 2. This would be a quadratic binomial. Moving on to number 5. Another similar question, it's just written differently. All right, so it says q of x is this cubic polynomial. Notice in the polynomial, k is a variable. So we're trying to figure out what this constant is. So if we divide by 3x minus 7 to be a factor of the polynomial, and this is something we haven't actually talked too much about in class, a factor of a polynomial, what that means is the remainder is 0. That's something we're going to spend a lot of time on in this unit. So if I divide 3x minus 7 into this polynomial, I'm going to leave k as k. I'm just going to do my long division as normal, and then we'll get down to a point where I know exactly what I need to make k. So 3x cubed, I want to multiply here as x squared to make 3x cubed, because 3x times x squared makes 3x cubed, minus 7x squared. Nothing different yet. That becomes a minus, that becomes a plus. These cancel, and we get a 3x squared, and the 5x comes down. What multiplies by 3x make 3x squared? Well, that's just x. So that becomes 3x squared minus 7x. This becomes a minus, this becomes a plus. So we wind up having 13x plus k. Not 13, 12. So now I'm asking myself, well, what multiplies by 3x to make 12x? Well, it's 4. If I multiply by 4, I wind up having 12x minus 21. So what does k have to be here so that this would come out to be a remainder of 0? That's my question. So remember, in all these other examples, if you notice, the last terms were always the same. You look at number 4, it was the same. Number 3, it was the same. Here it was the same. They're all the same. So if they're the same, when you subtract, they cancel. They become additive inverses. So what's the same? So that means k would have to be negative 21. Number 6 says compute the quotient x squared plus 9 divided by x plus 3. What's different about this quotient? So if I do x plus 3, x squared plus 9. What multiplies by x to make x squared would be x. So that gives me x squared plus 3x. Well, I need an x term there, right? So I'd have to put a 0x in. So when I do my subtraction, minus, minus, these terms cancel. 0 minus 3x becomes negative 3x plus 9. What multiplies by x to make negative 3x? So that would be minus 3. So I have negative 3x minus 9. Well, if I change my signs to a plus and a plus, these still cancel, but 9 plus 9, well, that's 18, not 0. What does this mean? Well, this means a lot of different things. One, it means there's a remainder, which I'm hoping you're all able to infer from all the long division work you did way back in elementary school. The more important thing algebraically is we can say x squared plus 9 does not have a factor of x plus 3. Because when x plus 3 is divided in, there's remaining pieces. Therefore, it's essentially an unfactorable expression. And that's it. In the next lesson, we'll be talking about synthetic division, which is just another way of dividing a polynomial. Hopefully this video helped, and hopefully you're watching these videos because there's really no other way of checking your homework.